In this lab I want to demonstrate how to do an all-around symbol and a field weld with the weld bead finding the tangent and going all the way around this standpipe. The black flag signifies that this part is welded to the base out in the field and not in the shop, and then the circle indicates that the weld bead goes all around. So let's look at how to set this up. So first thing I'm going to do is start a new part file, and I'm going to use inch units for this, but it could be metric units. And I'm going to go to the top view and I will find the top plane. I'll start a new sketch on the XZ plane, and I'm going to draw a center point rectangle at the origin. I will dimension one of these sides, so I'll dimension this side, say 10 inches. And I want this to be square, so I'll do this side is equal to this side. Now there is a square polygon tool that we could have used for this. If we did that, we would have to put a horizontal or a vertical constraint on one of these lines, otherwise it would be the same. And then I could either offset this, or I could draw another 2-point rectangle, and then I'm going to dimension the width of this as 4 inches, and again I'm going to do equal. I'll make this side equal to this side. Alright, I will finish this sketch, and then I'm going to do extrude, and I'm going to select this first rectangle, the larger rectangle, not the area in between, and then I'm going to flip that direction, and I will go ahead and accept a distance of 1 inch. Now I want to use that sketch again, and it became consumed by my previous feature, so I need to expand this, and I'll right click, turn on the visibility of the sketch, and then I'm going to do extrude again, and this time I'm going to select a smaller rectangle, and I'm going to go up a distance of 6 inches. And because I'm doing this as a weldment, I want this to be 2 separate bodies. Now we could create these in 2 separate part files, or we can do it as multi-body and either push those out into an assembly or use as is. So I'm going to tell it to create a new solid, and so right now it says solid bodies 1. I'll say OK, and now it says solid bodies 2. So I have 2 solid bodies. I'm going to turn off the solid body 1, so I'll right click, turn off the visibility of solid body 1, turn off the visibility of the sketch. I'm going to do fillet, and I'm going to select these 4 edges of the vertical piece, and I'm going to set that fillet radius to 0.5, and then I'm going to shell, removing this top face and this bottom face, and I will set that shell thickness to 0.25. Okay, then I'll turn the visibility of the first solid body back on again, and so we see we have a pipe and we have this base. Let's go ahead and name this. So I'm going to name this one base, and I'll click on this one and hit F2 or click twice slowly, and I'm going to name this one pipe. Okay, so we have 2 solid bodies within 1 part file. Now we could use this in a weldment, or we could push these solid bodies out into individual parts. Let's look at how to push these out into individual parts. I'm going to go to the Manage tab, and I'm going to select Make Components, and it tells me that I have to save this first, so I'm going to call this Field Weld Master. Let's put dash master. And then I'm going to come over and select these 2 components, the base and the pipe, as what I want to export, and I'm going to just call the assembly field weld. So I'm going to get rid of backspace over the dash master. Notice it'll put the extension IAM on here, and it's going to put these parts into the assembly. Now I've set up at the beginning, I set a project so that the files are saved in my project file location. So for each new project I create a new IPJ file. Now I'm going to leave it on the standard IAM file, but really what I want to do is a weldment. So if I wanted to do this without making a mistake, I would go ahead and tell it to do a weldment, but I want to make a mistake and show you how to recover from that mistake. So I'll just use standard IAM. I'll say next. We're given an opportunity to rename these files. It's probably safer to give the files part numbers rather than names like this, because we could have many different pipes, many different bases, and we could accidentally overwrite a file name using English words like this rather than part numbers. And if I wanted to scale this, I could scale it up or down. If I wanted to create a left or right mirror image or top or bottom mirror image, I could select mirror image. I'll just say okay. Okay, so now we see the building blocks over here. We are now in an assembly file, and we see our two parts, and they are grounded at the origin. Now if we wanted to put constraints on these, we could unground these and put constraints, but they're already in position. And one advantage to using a master file is that if we make any changes to the master file, those changes would automatically be reflected in our assembly file. So now I want to do a weldment, but I made a mistake intentionally in this case, that I forgot to start from a weldment template. So if we go to the environments tab, here we can click convert to weldment, and it'll tell us that once it has been converted, you can't go back. Actually, there is a trick that you can use to go back if you know the trick. I'm going to go ahead and say yes, and it asks us for the standard that we want to use and what material that we want to use. I'm going to set this as steel, and I'll say okay to that. Alright, then I'm going to go to my welds, and I'm going to do a fillet weld, and I will set the size to be 0.375, and I'm going to select for the first face. I'm going to select this face. I need to make my selection tool active, and then I'm going to do chain, and I'm going to select the second face, and we see that with chain on, it goes all the way around in one pick. I'm going to create a welding symbol, and I'm going to say same side 0.375, and then I'm going to tell it I want to do a field weld, so I'll set the flag for a field weld, and I also want this to go all the way around, and so I'm going to click on the all around symbol. That'll put that circle, and we'll say okay to that. I'll drag my symbol out here. So here is our symbol for the field weld, however we want to arrange this on our drawing. And so that's simple for a all-around weld and signified as a field weld in Inventor. Before we go to the drawing, we always need to click this return, because right now we're in welding environment. We could be either in the prep environment, the weld environment, or the machining environment. We need to return to the assembly environment before you create the drawing, or you'll get an error about the model being in a rolled back state. Make sure that you save your assembly. So in SolidWorks, I'll click on the white sheet page to start a new part file. Your screen might look slightly different than this. It might look like this. It might have some other appearance, but I'll select part, and then I'm going to start a new sketch on the top plane. So I'll right click on the top plane, I'll do sketch, and I'm going to do a center point rectangle, and I'll click at the origin. I'll come up to place that rectangle, and I'm then going to dimension the height of this rectangle as 10 inches. Now watch your units. So I see that my units are millimeters. I want this to be inches, so I'll do 10 IN for inches. And I'm going to come down here where it says custom, and I'll select this to inch pound seconds, and I'll have to go back and edit my sketch now. So now I see this as inches, and I'm going to hold down the control key, and I'll select a vertical line and a horizontal line, and I'll make those two lines equal. Now there is a polygon tool here. We could have just used the polygon tool. If we used polygon with 4 sides, we would have to put a horizontal relation or a vertical relation on one of these lines. I'll do this again, so I'll do another polygon, and I'm going to dimension this one. I'll do this one as 4 inches, and again I'll select a vertical line and a horizontal line, and I'll make those equal, and I will finish sketch. Now because I clicked finish sketch, if I go to the features tab and I do extrude, it's going to ask me to select a sketch. I could avoid that message by pre-selecting the sketch, but let's go ahead and do it this way so that we see that message. So I'll do extrude, and it says either to create a sketch, number 1, or number 2, select an existing sketch. So I'm going to select this, and you have to pick the very edge of it, or the actual geometry. You can't just pick in the middle. I'm going to pick on the edge of this, and I want this to go down, and I'm going to do a distance of 1 inch, and we'll say okay to that. And I will go ahead and save my part. I'm going to call this field weld. And then I want to use that sketch again. It was consumed by that feature, so I have to expand the feature. Here we see the sketch. I'll right click, I'll select show, and then I'm going to go ahead and select one of the lines in this smaller rectangle before I do the extrude. And so we see that it finds that contour. I'm going to set this distance as 6 inches. And I want to make sure that I uncheck merge result so that I have two separate bodies that need to be welded together. So I'll uncheck merge result. I'll say okay to that. I will right click and hide the sketch. I will come up to my solid bodies folder. I'll right click on extrude 1. I'll hide extrude 1. I'll select one of these edges and I'll select fillet, and I'll select the other 4 edges, and we can select right through the body, and I will set this as a radius of 0.5, and I have it set to full preview so I can see those fillets as I put those in, and I see I missed the 0.5, and now I tab and I can see that I have my fillets preview. I'll say okay to that. I will then do a shell, and I want to remove this top face, and I want to remove this bottom face, and that shell thickness I want to do as 0.25. We'll say okay to that, and so here we see our shelled part. I'll turn the base back on again, so I'll do show, and I'm going to click twice slowly on that first one or hit F2. I'm going to call this base, and then I'll select twice slowly on the first body, and I'll call this pipe. Again, we might give these part numbers rather than English names because we might have many base components and many different pipe components. So I will save my part, and then I'm going to go to the Weldments. Now we saw how to load the Weldment tab. You right click and go to tabs, and you select the tabs that you want. In this case we want Weldments. We saw in a previous lab how to add this fillet bead to add a physical weld bead to our components, and that is what I'm going to do in this case. So I'll do fillet bead. I'm going to set my size as 0.375, and I have tangent propagation turned on. For face 1 I'll select this face, and for face 2 I'll select one of these side faces. We see that it propagates that tangency going all the way around. I have it set to add a weld symbol. I will say okay, and if we look around here someplace we should have that weld symbol on here. Actually, it may have been on the whole time, but I didn't see it. It was down inside of my part. Now notice there is a line above here, and when I see that I know that I have an ISO standard and rather than an ANSI standard. So I'm going to attempt to change that. I'm going to come up here to options, and I will go to the document properties, and instead of ISO standard I'm going to set this to ANSI standard, and we'll see if that makes the change to our weld symbol. And I see that that did change the weld symbol. I might also want to put that to 3 decimal places. Now I'm not sure in SolidWorks how to get the field weld symbol and the all around symbol while we're in the part model, so I think we would have to do this in the drawing. If you know of a way to get this symbol completed in the part, actually I may have just found it. I'll double click on that, and I also may want to change the number of decimal places, but a weld really we're not going to do to 3 decimal places on an inch. But let's see if we can find, notice here is the contour, whether we want a flat or a convex or concave. And for our weld symbols, well, I hunted around in here to see how I could make this around active and make this field weld active, and I don't see how to make that active. It can be done in the drawing, but if you know how to do this in the part level, put a comment below and let me know how to make these active. In this case we modeled this square pipe, but in the future lab we'll see how to do built-in structural members where we can select a standard square pipe from a library. And of course we'll be able to select those structural frame members from either Inventor or in SolidWorks.